Okay everyone, for this lesson we're going to learn how to solve non-homogeneous linear differential equations with constant coefficients. Okay, so for this video, we are going to review some concepts that we need from lesson 3.1 and then discuss the limitations of the method of undetermined coefficients. Okay, so the first concept that we need to review is the difference between a homogeneous and non-homogeneous equation. So for homogeneous equations, the right-hand side is equal to 0, right? And for non-homogeneous equation, instead of 0, we have g of x. Okay? So this is a function of our independent variable, which in this case is x. Okay? So that's one of the concepts that we need to review. And then also, the general solution of a non-homogeneous equation is y is equal to yc plus yp. Okay, so what is yc? So yc is the general solution of the associated homogeneous equation. Okay, so what is that in this case? So it is basically this one. So as you can see here, the left hand side right here is the same as in our the left hand side of our non-homogeneous equation. They only differ here. Okay, this is 0 instead of g of x. Now if we solve that using the auxiliary equation method or reduction of order, we can get yc, right? Now let's go to the second part of our general solution, which is yp. Now yp is the particular solution. Now what is this particular solution? So yp is the function that if you substitute it to our left hand side here and get its corresponding derivatives, it will satisfy this non-homogeneous equation. It will satisfy our equation. Now if you get that using the method of undetermined coefficients, we can then get the whole general solution of our non-homogeneous equation. Okay, so that's basically it for the concepts that we need to review. Let us now go to the limitations of the method of undetermined coefficients. So the limitation is that, of course, the first limitation is that our coefficients has to be constant, right? So an minus 1 all the way to e0 has to be all constants. And the second one is that g of x has to be a finite sum or a product of any of the following types of functions. So we have a constant c, we have polynomial functions, so we have linear functions x plus b, or quadratic functions ax squared plus bx plus c, and so on with increasing degrees. And we also have the exponential function e raised to alpha x. We also have the sine function sine beta x, and also the cosine function, the form of cosine beta x. Okay, so you can only use this method of undetermined coefficients if g of x is a finite sum or product of these different function types. Now in the next video we will discuss the methodology, and we will get a clear idea of why this is the case if we go through the methodology and also do some examples afterward. Okay, so see you in the next video.